Reviewing SHM basic and spring question, that's Juno 3, question 6. You have two graphs. Very often these graphical questions are the hardest kind of questions you get to do. So we have a graph of displacement against time, and we have a graph of velocity against time, and as you would expect, they are out of phase because when the velocity is positive, when the displacement is positive, the velocity is negative. For that first quarter cycle. So it says, figure 1 below shows the position and direction of travel of the mass at the instant labelled x. Complete figure 2 to show the spring and the position of the mass in its direction of travel at the instant y. Well, x is above the equilibrium position and moving up. Y is below the equilibrium position and moving up. So whilst I can't draw on here, and neither can you unless you print it, you will have your spring drawn so that the mass is here, below the equilibrium position, and both the velocity and the acceleration are upwards. And the acceleration is down in this case. So, first part of the question, your spring is drawn so that the mass is below the equilibrium position and moving up. Second part of the question, the acceleration here is down, the acceleration here is up. Then it says, using the information from the graph, determine the amplitude of motion, that is to say, the maximum displacement from rest position. So the maximum displacement from rest position would be, there's a rest position, there's a maximum displacement. It is 0.065. Now there is some tolerance to that, 0.003 either way. So 0.065 meters there. Now the spring constant. Well, what do we know? We know the amplitude now. We know the mass. Up here, looking at this, we can get the period of oscillation from either of these graphs. We can get the maximum velocity, or indeed any velocity we like, but the maximum velocity would be handy. And the reason being that we have a formula for the maximum velocity. So we know from our earlier work that the period is 2 pi root m over k, and it's k we want, and we've got m. So if we had the period, we would then have the value of k. So we could read the period off there. You might say, well, I'm not wild about doing that because I might make a mistake. It's easier to read the maximum velocity off. So if we did that, what we could do is say, well, we also know that the period is 2 pi over omega. So omega is root k over m, and V max is a omega. So if we simply read off V max from the graph, and that's a nice easy thing to read off, 0.5, 0.6, 0.7, meters per second. So then we can say 0.7 then is 0.065 times k over 0.4, which gives us k. Now, as I said, you don't have to go through all that. You can just say t is 2 pi root m over k. You know m. You can read period off the graph, and out will drop your answer. But the answer is 46 newtons per meter. Don't forget the units.